right, 3.8, the tangent function is what we're doing today. A shout out to Kyler and Lane in Chicago. If you are listening to this recording, text bananas, comment bananas on the YouTube channel. All right, here we go. Recall.
We first introduced the tangent angle in topic 3.2. We defined the tangent of an angle as a slope of the terminal ray, or as a ratio of the angle's sine to cosine values.
All right, fantastic. Sine, what do we think of? Y. Cosine, we think of what? X. What do we think with tangent? Y over X. Okay, so that's what we're going to be doing here. All right, keep going.
As we did previously with sine and cosine, we can use our understanding of the tangent function to develop its graph. Let's look at the slope of the terminal ray as our angle theta increases from 0 to pi over 2.
All right, so if we look at 0, all right, this is our angle 0 in radian measure. And so what is tangent again? It's y over x, right? And so what would my y be at 0? 0. What would my x be? 1. And so my tangent would be 0. Yes? And so let's kind of keep moving up here. And so this one would be at pi over 6. Okay, let's just say it's at pi over 6. So what would my y be at pi over 6? 1/2. What would my x be? Square root 3 over 2. And so then you'd cancel out your 2's. You'd have 1 over square root 3. You'd rationalize. You get square root 3 over 3. And so then we can do it in the middle. So let's say it's at pi over 4. And so what's the tangent at pi over 4? Square root 2 over 2 over square root 2 over 2, which is equal to what? 1. And so I'm kind of increasing here, all right, because my y is getting bigger and my x is actually getting smaller. Does everybody see this? All right, and so this would be at like pi over 3. We're not going to do it. But let's say this one. Let's see that we get really close to that y-axis. So we get really close to this pi over 2. And so this would be a really big y, yes? However, it's a really small what? X. So if we have a really big y over a really small x, what does that go to? It's really big, right? Okay, a really big y over a small x, I'm going to get a really big number. So if we actually go to like pi over 2 though, what would we get at pi over 2? 1 over 0. Well, what's 1 over 0?
0.
It's undefined. However, as we get close to pi over 2, it's going to get really what? Big. And what do we call really big? Infinity. We call that infinity. All right? So let's keep going, Aiden. You're doing great.
When theta equals 0, the slope of the terminal ray is 0. As theta increases, the slope increases as theta approaches pi over 2. The slope gets steeper and steeper. And when theta equals pi over 2, the terminal ray is now vertical. The slope of the vertical line is...
All right, what's the slope of the vertical line? It is undefined.
We can see now that when we say the slope is undefined, it is because it is infinite.
All right, let's read this one. All right, so we have a limit as theta approaches pi over 2. And what's this little negative sign mean? That means from the left. All right, it means from a little bit less than pi over 2. And so if we think of this, this is the way our unit circle goes, yeah? It goes counterclockwise. Does everybody agree with this? And so when I approach from the left of pi over 2, it's actually from this direction. All right? It's actually kind of like what you would actually think of as your right. But it's because it's the left because it's less than pi over 2. Does everybody follow how we did that? And so if I approach it from the left or less than pi over 2, it's going to get really big. And so that's why we call this positive infinity. So you ever see how that happened? All right. Now, I want to kind of go the opposite way before we move on. What if I approach pi over 2 from the right? That means it's a little bit more than pi over 2. Does everybody agree with that? So what's my y value? Because tangent's y value. So, or it's y over x. So what's my y value? It's really what? It's big. And my x value is a really small what? Negative. And so if I have a really big positive over a really small negative, what is that? That's negative infinity. And so that's kind of what we're going to discuss right here. And so it starts out at like negative infinity right here. And then this one's going to be negative. It's going to be a fairly big negative because my y is bigger than my x, but it's still it's going to be a positive over a negative, which will give me a negative, right? And so then what's it going to be when we get to pi, though? It's going to be 0 over what? Negative 1. What's 0 over negative 1? 0.
As we continue from theta to pi, theta to 3 over pi, 2, we can see the slopes are now positive again in progress from the slope of 0 when theta equals pi. Two slopes that increase with the bound theta approaches 3 pi over 2.
All right, beautiful. So let's talk about it. And so what's tangent again? It's y over x. Now, what's my y here? It's negative, yeah? But this is a really small negative, and then it's over a negative, all right? And so it's going to be a small negative over a bigger negative, but it's still going to be what? Negative over negative is a positive. So tangent in the third quadrant is what? Positive. How about the first quadrant? How about the second quadrant? Negative. Okay, so if we can at least get that, that'd be great. And so then we still got tangents, and then let's go to this axis here. And so I'm going to approach this axis. And so this is a really big what for my y value? Negative. And then it's a really small what value? A negative x value. And so if I got a big negative y over a small negative x, that's going to be what? Positive infinity again. All right, exactly. Because what's happening at 3 pi over 2? What's the tangent at 3 pi over 2? What's my y? Negative 1 over 0. So a number over 0 is still undefined. All right, and that's where we have that going on. All right, cool. Keep going.
Key concept. Each side of the terminal ray is vertical. The slopes are undefined. When we graph the tangent function, this means that we'll see
vertical asymptotes. Vertical asymptotes.
when theta equals pi over 2 and theta equals 3 pi over 2, each half turn around the circle will create another vertical asymptote.
All right, fantastic. So you have vertical asymptotes at pi over 2 and at 3 pi over 2, yes? And then every one after that, okay? Because it's a cycle. Now, we've already talked about why they are positive infinity or negative infinity and so forth. We talked about that as part of our unit circle. But how long did it take to complete its cycle? What was its period? Pi. So our period of sine and cosine is actually what? Sine and cosine is 2 pi, right? That's how long it takes to complete its cycle normally. And so the normal cycle of tangent is what? Pi. And so what happens in quadrant 1 is the same thing that happens in quadrant 3. What happens in quadrant 2 is the same thing that happens in quadrant 4. It's a cycle, all right? And so that's how that one's going to work. Now, tangent, okay, so tangent is this kind of curve, okay? And it's going to keep repeating over and over just like sine and cosine does. And so it's going to go up. That's kind of how you should start thinking of it. The other thing is that it kind of is crossing the x-axis in the middle. Unless it's shifted, it's crossing the x-axis in the middle. And so I got to talk about a few things. So our period now is going to be what? Pi. And so the way we get the period is we take our pi, divide it by b, just like normal. Okay? Just like what we did with sine and cosine. Instead of 2 pi, now it's pi. I want you to actually, Trace is going to read this part. Vertical dilation.
Vertical dilation of the graph of y equals tangent of theta by a factor of a.
Absolute value a. All right. So the a does not always represent the amplitude in sine or cosine either. It kind of does, but it sometimes is an a is a negative because the negative makes it do what? Flip. All right. This a is not an amplitude because I don't have a midline, nor do I have a max or a min for tangent. Does everybody follow me? Okay, and so this is going to be a vertical dilation. Technically, I think of it as a stretch. All right, it like moves quickly up, and we'll talk about that as we move on today. All right, keep going. Phase shift. Yep.
Phase shift of negative c units, horizontal translation.
All right, so again, if we add or subtract inside here, we're going to move left and right. Okay, and it kind of does the opposite of what you might think, just like all of the other ones. All right, keep going on the vertical translation.
Vertical translation of the graph of y equals tangent of theta by d units.
All right, so again, this one starts at 0. It's not a midline, okay? So tangent does not have a midline. But if I like moved up 2 here and I kind of made my little curve, my d would be 2, Okay, it's that vertical shift going on, or that vertical translation. Okay?
Example 1. A portion of the function f is shown above. The function f can be written as f of x equals a tan of b of x plus d. Where a, b, and d are constants, find the values of a, b, and d.
All right, so this one's kind of hard to solve for A because it doesn't give a specified point, but we're going to do this one anyway. However, let's go. So let's find B. All right, so B definitely works with our period, yes? So what is my period on this one? How long did it take to complete its cycle? It took pi over 2. So from negative pi over 4 to pi over 4, we get pi over 2. All right, so that's how long it took to complete its cycle. Now, what do we want to do? What's our normal period? Pi. Pi is our normal period of tangent. And so we'd have pi over b, which is equal to pi over 2 on this one. So what does b equal? 2. All right, pretty easy. Now let's talk about d. And so d represents our vertical translation. And so did I shift up or down on this one? No, I didn't shift at all. And so guess what d is? D equals 0. All right. And so now we end up having f of x is equal to a tangent of 2x plus 0. And so this is how we're going to solve for a. A is kind of hard to solve for, honestly. And so this is the way I'm going to do it. There's not really a point here, but I kind of look at that point and I'm like, hey, that's kind of in the middle. Does everybody see how this is kind of in the middle here? And it kind of crossed at 1. Does everybody follow that? All right. And so without giving a point, this is actually a difficult problem to do. But I'm going to say that point is there. All right. And so what x value, or my input value, would I have? It's half of pi over 4, pi over 8. And so my ordered pair there would be like pi over 8, comma what? 1. Okay, and so all I'm going to do is I'm going to substitute in 1 for my f of x because that's my output. And then I have a, and then tangent of 2 times, what's my x value? What was my input that we just talked about? Pi over 8. And then plus 0 still. All right, and so now let's evaluate. So what's 2 times pi over 8? Pi over 4. And so what's the tangent at pi over 4? 1, because it's square root 2 over 2 over square root 2 over 2. And so my tangent of pi over 4 is 1. And so a is equal to what? 1. All right, so I'd have 1 times a equals 1, a equals 1 in that one. All right, and so I solved for my a, which is 1, my b, negative or positive 2, and my d equals 0. All right. All right, let's keep moving on example 2 now. Trace, keep going.
The function h is defined by h of x equals 4 tangent of 2x plus 5. What is the period of h?
All right, so this is a pretty easy one. What would be a period? What's my normal period? Pi. So I take pi divided by b. What is my b? 2. And so I have pi over 2. And so my period is just pi over 2. All right, pretty easy on that one. Now, I want to talk about this one a little bit more in depth. What does this 5 do? It shifts it up 5. All right. What does this 4 technically do? It's a vertical dilation of 4. And so if I were to have an a of 4, on this one, instead of crossing at pi over 8, 1, it would cross at pi over 8, 4. If this one if this a was 4, okay, it would actually move up fast. All right, that's what that a would do. Now, the vertical asymptotes are still going to be the same. The period's still going to be the same. However, it would go fast up. That's all it would do. All right, let's keep moving. All right, let's keep going. Go, Ethan.
Let g be the function defined by g of x equals 2 tangent of x over 3 minus 1. Which of the following gives the vertical asymptotes to the graph of g?
All right, fantastic. Where are my normal vertical asymptotes of a tangent function? At pi over 2's and what? 3 pi over 2s. All right? And so I need you to know that. Like, that is something that you have to know. Because they're undefined, remember? Because tangent at pi over 2 is undefined. You get a number over 0. That's what makes a vertical asymptote. And so we're going to set pi over 2. So we're going to have x over 3 equal to pi over 2 plus, how often does it happen? What is the normal period of tangent? Pi. And so we're going to call this pi k. All right. And before this year, I used to call them n pi's for n being an integer. However, this is the way we're going to do it now. It's the same thing. Now it's a k instead of an n. Not a big deal. All right, and so now let's solve for x. And so now, what do? We multiply everything by what? 3. And so then I'd have x equals what? 3 pi over 2 plus 3 pi k. And so which one does it match up with? C. All right. And so again, where are your normal vertical asymptotes of a tangent function? Pi over 2 and 3 pi over 2, or negative pi over 2, pi over 2, 3 pi over 2, so forth. All right. And so again, what's my normal period? Pi. However, on this one, it got dilated a little bit. Okay. All right, let's keep moving.
Example 4. A portion of the function k is shown above. Which of the following could be the expression for k?
All right, fantastic. So, what do we notice about this function? We should notice a couple things on this one. It shifted. What did it do shifting? It shifted down, exactly. And so when it shifts down, what does that help solve for? A, B, or D? The D. It helped find our D. And so what was our D? D equals -2. Okay? Because it shifted down 2. And so which ones am I in between right now? A and C. So I'm in between A and C right now. Those shifted up 2 on those choices. And so now I need to figure out my period because I need to solve for my B. Yes? And so what's my normal period? Pi, right? And so I'm going to have pi divided by B, which is equal to what? What is the period of this one? 2 pi. And so if we go from -pi to pi, that period would be 2 pi. And so now I multiply by b, I divide by 2 pi. So what does b equal? 1/2. And so now, which one does that match up with? A. All right. All right, let's keep going. All right, so on finding these values using our unit circle, I'll do a couple with you before I set you free. All right, and so now we have tangent of pi over 6. And so let's do it. And so what's the tangent at pi over 6? What's the y value? 1/2. What's the x value? Square root 3 over 2. And so what cancels? The 2. So I'm left with 1 over square root 3. What do we need to do with that, though? We rationalize it. So we multiply by what? Square root 3 over square root 3, which is equal to? Square root 3 over 3. All right, let's do another one. So let's look at tangent of pi over 4. And so what is the tangent at pi over 4? What's my y value? Square root 2 over 2. What's the x value? Square root 2 over 2. And so what do we get? 1. All right, let's do D. I want to do D next. All right, and so let's do tangent at 5 pi over 6. And so what do we need to do here? What's my y value of 5 pi over 6? 1/2. And then what's my x value? Negative square root 3 over 2. All right, and so what happens? My 2's cancel, but I need to rationalize, so then I get what? Negative square root 3 over 3. Part C. So if we have tangent of pi over 3, what do we got? Square root 3. We've got square root 3 over 2 over 1/2, so we got square root 3. All right, so our tangent of 4 pi over 3, and so what's my y value? Negative square root 3 over 2. What's my x value? Negative 1/2. So the negatives and the 2's cancel, so we're just left with just positive square root 3. All right, because it's in the third quadrant, it's going to be positive. All right, because it's a negative, negative. All right, tangent of 7 pi over 4. And so what's my y value? Negative square root 2 over 2. And then what's my x value? So we end up with negative 1. Love that. All right, so now we have tangent of 3 pi over 2. What do we got? Undefined. You shouldn't even have to think about this. All right, it's technically negative 1 over 0, yes? Okay, which is undefined. It's a number over 0. However, where are your vertical asymptotes going to be? At what? At pi over 2's. All right, at pi over 2's, they're going to be undefined. Okay, all the tangents. All right, so tangent of pi. And so what's my y value? 0. What's my x value? Negative 1. And so I still get what? 0. And so now I have tangent of pi over 2. And so what's the tangent of pi over 2? Undefined. All right, because they're a vertical asymptote there. All right. So